Welcome to this video on Applied Thermodynamics-II, focusing on mechanical engineering concepts relevant for exams like UPSC and SSC. Let's look at this question. The efficiency of the Carnot cycle may be equal to which of the following cycles when running between the same temperature limits? The correct answer is the Stirling cycle. Next question. Which of the following is not a vapor power cycle? The answer is the Otto cycle, which is a gas power cycle. Moving on. The amount of energy added by heat transfer to the cycle to produce a unit of network output is called? This is defined as the heat rate. Next question. Thermodynamic processes constituting a Rankine cycle are isobaric heat addition, adiabatic expansion, isobaric heat release, and which of these? The correct completion is adiabatic pumping. Consider this. Rankine cycle efficiency can be improved by? The correct answer is all of these, as efficiency can be improved by reducing heat addition in the boiler, increasing expansion work, or reducing feed pump work. Next, the Carnot vapor power cycle comprises of which following processes? It consists of 2 isothermals and 2 adiabatic processes. Finally, a throttling process can be shown on a Mollier diagram by? It is shown as a horizontal line on the Mollier diagram. Let's consider the Helmholtz free energy during a reversible isothermal and isochoric process. In this specific process, the Helmholtz free energy remains constant. Next question. The thermodynamic processes constituting a Rankine cycle are isobaric heat addition, adiabatic expansion, isobaric heat release, and which of the following? The correct answer is adiabatic pumping. On a Mollier diagram, how can a throttling process be represented? A throttling process is represented by a horizontal line on the Mollier diagram. What is the critical pressure ratio for air flowing through a nozzle? For air, this ratio is approximately 0.528. Next, if the back pressure of a nozzle is below the design exit pressure, what do we call the nozzle? Such a nozzle is referred to as an under-expanding nozzle. What is the state called when the back pressure of a nozzle equals the critical pressure? This state is known as the choked operation of the nozzle. When supersaturation occurs in a nozzle, what effect does it have? It causes an increase in discharge, a reduction in exit velocity, and an increase in dryness fraction and entropy, so the answer is all of these. Finally, how is the degree of supersaturation defined regarding steam flow through a nozzle? It is defined as the ratio of saturation pressure at the temperature of the metastable state to the actual pressure of the steam. Next, consider the case of subsonic flow. How can an increase in velocity be achieved from inlet to exit in a duct? For a subsonic flow, an increase in velocity is obtained from a duct with a converging cross-sectional area. Now for supersonic flow, what type of duct is required to increase velocity from inlet to exit? For supersonic flow, the increase in velocity is obtained from a duct with a diverging cross-sectional area. What is the difference between the saturation temperature in stable equilibrium and the actual temperature of steam in metastable equilibrium? This difference is known as the degree of undercooling. In a steam turbine, if leakage along the mating surface is reduced by using the principle of steam throttling, what type of sealing is used? This is achieved using labyrinth glands. Which of these components is not considered a part of an impulse steam turbine? The correct answer is airfoil-type blades, which are characteristic of reaction turbines. Finally, in which type of compounding of impulse steam turbines does the ratio of blade velocity to steam velocity remain constant? This constant ratio is a characteristic feature of pressure compounding.